Hi, welcome to Draw Plans. I'm Tom Norris, and for today's tutorial we're looking at block and beam floors. So if we look at the photograph in front of us, we can see a suspended block and beam floor in progress. As you can see, the end beams are sitting on the inner leaf of a wall, supported in the middle, and you can see they're dropping them in. So let's have a look at a few diagrams here and let's start getting familiar with how things work. Let's look at this one. So this is basically when they're putting in block and beam, they sit them on the wall and then they use blocks for spacers. So they don't go filling it in. What they do is basically get the beams in place and using blocks then as spacers, and that's generally how they lay it out. When it comes to the actual overhang, it has to be the width of the brick. It has to be a minimum of 100 mil sitting, not 50 mil, 40, has to be 100. So that's really important, whether it's sitting on a dwarf wall or whether it's sitting on the inner leaf. And it also needs the DPC. Let's have a little look here. So that's your foundation, that's your trench block or engineering block, and if you come around here you'll see your beam. So your beam is sitting basically on the inner leaf, which is this wall, and you can see your blocks dropped in between the beams. Normally there's a thin or light or damp bit of muck put on top just to fill in all the little gaps, almost like a liquid screed, just a 5-10 mil to fill in all these little gaps. On top of that you've got insulation, and then you have concrete screed. This one's got underfloor heating. And as you can see, you've got a little bit of insulation coming up here, and then you've got skirting, dry lined or dabbed out walls, and you can see your cavity wall here with a brick outer finish, block inner finish, and it's pretty simple, pretty straightforward. But I say that because I've been doing it for donkey's years. So let's have a look at a section here. This is basically a section where we're showing the beams, a standard 215 block dropped in between, insulation on top, and then a screed on top of that again. So when it comes to the screed, the thickness varies, but depending on what you're doing, but 65 mil is about the minimum, and sometimes you'll need steel in it, and again that'll be down to the engineer who's detailing it for you. If we look at this section again, you can see the beams, the blocks, insulation, the finished screed. That insulation here is very important, don't leave it out. And where the last block or where the last beam next to the wall is, that should be filled with concrete, and that's your standard wall. So let's look at the next one. What are we looking at here? Another section. Nothing, and I'm not quite sure why that one's there. It's probably because there's sometimes you'll work both ends to the middle, or work from left to right, popping the beams in, and you might have the need to cut a block or cut a whole sequence of blocks like this. Cut a whole sequence of blocks. They're showing you effectively how it sits. Again, there'll be times you have to join two beams together. Always get a bit of concrete in between. Infill between the beams. Right, so again, look at it. It couldn't be more simpler. Drop your beams, space them out with a block on either end, and then just fill in. And where you have the last one, that gets cut as you need to. So we're watching this chap here, who's going to have a really sore back at the end of the week from popping these blocks in. Now, sometimes there'll be specified different types of block, meaning dense. Dense blocks, sometimes they're specified as in heavier. They'll be heavier, that's for sure. But again, it's down to the engineer who is specifying. So what else am I going to show you? I've got a detailed section here. We're going to get to that in a few minutes. I'm just kind of cover what I can through the photographs. Again, that looks like a dwarf wall. The beams are sitting on top of the DPC. The spacers are in, and that's how you lay it out. But we're going to talk about underneath in a minute when we look at the detailed section. This is 4 houses, or 4, well, these are actually shops. This is a shop and 3 floors above, and this is the ground floor. And it's showing, this is one of our projects, so it's showing how the beams are to be installed, sitting on the inner leaf on each wall. They go halfway in, halfway in, halfway in. So all of the beams for all of the 4 floors, what it was, we had to raise the height of the floors for flood mitigation. So we had to put a block and beam floor throughout the ground floor on these 4 buildings. To raise it by about 1 meter, which means doors and windows, everything else had to be raised. But they basically, these are, as I say, these are the boundary or party walls, and the blocks go in, the beams go in, at least 100 mil into each wall to sit on the block, on the brickwork. One of the things you got to consider here is that when all of the floors are loaded onto the boundary walls, it means that all the internal walls that sit on top of these beams, or the block and beam floor, they're all going to be sitting on the block and beam, which means like the staircase is going to sit on it, the partitions are going to sit on it. It means that the superstructure, meaning the boundary walls, are taking all of the weight of everything. And unlike, say, on a traditional flooring where you'll have dwarf walls taking some of the weight and weight getting displaced and moved around. So again, it's very important to have the engineering calculations for this kind of setup, because on a complete building, as I say, you're moving all the weight to the boundary walls rather than sharing it out through dwarf walls and spreading it differently. So always make sure you have engineers' drawings or engineers' calculations with that kind of setup. Right, so let's move to the block and beam detail section. As you can see here, this is your foundation, or I guess it would be your trench blocks, etc. But so you've got a beam here, and you've got a block, beam, block, beam, block. Now what you have down here, what we're showing is 75 mil concrete binding layers or blinding layers. So basically what you have to do is you have to dig out way more than the height that you're going to position your block and beam floor. You have to dig out. You need 150 mil air void. And that air void has to have loads of air bricks at the end. And the number of air bricks will be a calculation done by your engineer, because it's quite a few and it's going to surprise you. And then underneath, that's generally dug out and filled in with concrete, or at least blinded with sand. But you got to have this 150 mil void underneath your block and beam to get airflow going. So you've got your, as I say, you've got your beam here, then you've got your your block. You've got what have we got? Let's just have a look. You've got your right on top of the block. That's your DPC, and as I said to you, in good practice is to fill in all the little gaps between the block and the beam with a wet, liquidy sand cement mix. Top of that, you got your DPC, which is here. Then we got the insulation. So let's see what they're saying, because it's normally about 100 mil. So it's 90 mil insulation. I generally go for 100, but again, you can get away with 90. And they're showing 75 sand and cement, whereas I know 65 is minimum, 75 would be better. This could have underfloor heating in it. It could have steel in it for a variety of reasons. Again, it's down to the engineer. This is the normal wall. So remember, just keep, that's the important bit, and that's the bit that lets people down. And the ends of the beams are sitting on the inner leaf of the wall, which means at least 100 mil. That's about it, really. Can't really show you any more, but this little diagram is great. So what is a beam and block? Inverted T-beams made of pre-stressed concrete, similar to train rails. These beams are cut to a specified length determined by the construction drawings. On site, they are laid perpendicular to the supporting blockwork walls that make up the inner leaf of the footings at ground floor level. The rails rest on a damp-proof course and have 100 mil bearing. In other words, they cover the whole width of the inner leaf, which would be, in this diagram, this beam would be going in, basically touching the insulation there. 100 mil, and it would be sitting on the damp course. So the damp course we can determine as about there. That's about it, really. So I think you've got everything you need to know here. And as for putting a block and beam detail section, you've got all the ingredients there. So what I suggest is you have a good look, copy it out and start drawing it. That way you'll have your own detail section for a block and beam floor, which you can use over and over once you've drawn it. Especially you've drawn it in CAD and hold it in CAD. You make a PDF copy and then it's put in as detailed sections within your drawings. Okay, that's about it. That's all I can tell you about block and beam floors. Thanks very much for watching. See you on the next lesson. Bye-bye.